have at the top here the flocked sample that had the SAB seeds, and right under is just the one with SABs, which shows two things. First, that the SABs clearly were able to increase the oxygen in the water column during the day period. And secondly, that when flocked, the SABs showed a greater ability to produce oxygen in the water, which we will address later in the results. This was reflected in the biomass that we observed in each one. The ones that were flocked showed a significantly greater biomass than those seeds that were allowed to germinate in the absence of the flock process. This was due in part, we believe, to the fact that the seeds were able to germinate quicker and more effectively, because when the flock brought them down, it submerged them and allowed them to achieve the anoxic conditions required for germination. We also saw that those that were in the flock conditions were more anchored to the bottom and less inclined to float freely away, which is good if we're targeting an area that is devoid of SABs. The toxin results were somewhat less clear-cut, but we did clearly see at the start that after the flock, toxin, which was present in a high concentration in the water column, was taken down. Additionally, there were lower levels found in the flocked than the non-flocked, suggesting that our method is able to reduce the amount of toxin in the water column. This is, however, about as clear-cut as we would have liked. Now, this is a very busy graph showing the nutrient data, but it's more clear here in this bar graph here that we can see that at the start of each experiment, you see the levels of ammonia. And then you see 3 days later the levels, but then most importantly, you see the trends at the end. And all of our results that contain SABs showed significantly decreased levels 30 days after flock chelation versus those that contained the algae, which showed an upward trend. The nutrients were on the rise versus on the decline. We also observed these similar patterns when looking at nitrate and nitrate. Specifically in this, we saw that the flock process was very beneficial in removing a lot of these nutrients from the water column. As you can see here, that those trials that were flocked, or non-flocked, versus flocked, were higher overall versus those that were not flocked. And you can also see at the end here, as the plants continue to mature, a overall decline reaching towards the control, which is possibly, if we conducted the experiment over a longer period of time, it would have reduced to a more control level. And now I will conclude my portion and pass it off to the socioeconomics team.
Hi everyone, I'm Hannah. I'm part of the socioeconomics subgroup. So while the flocculation subgroup analyzed how the makeup of the flocculation mixture itself would work, the impact subgroup saw how it would affect Chesapeake Bay and the ecological consequences. We're actually addressing the logistics of applying our mixture to the actual bay. So our long-term goal for Team Green is to take our research and apply it to the actual bay with government support. So in order to do this, we have to do 3 things. First of all, we have to prove that the mixture works, which the flocculation subgroup has already done. The second is to prove that that it is affordable, that it's not out of our budget, that is reasonable to do. And the third is to prove that constituents are willing to support it. So for the second and third, we conducted a 2-part study. First is to survey the constituents of Maryland, and second to analyze the costs. So the reason we have to survey the constituents of Maryland is because in Florida in the 90s, scientists actually found a way to mitigate the red tide booms. I'm sure that you may have heard of those. And it was all ready to go, but because the public decided to dissent and say, no, we do not support this, the scientists wasted all their time and could not go further with their research. So we split this up into finding out how much each set of clay costs. The local clays cost nothing because they're actually on the side of the bay, but they would cost for transportation gas mileage to transport from the actual site where we're collecting the soil and the actual base that we were applying the mixture. The clay that we would import from Georgia, like for example, the TLE Kaolin Company, would actually cost money to buy and also increase the transportation cost because we're importing it from Georgia. And we also had other costs such as the chitosan the barge boat rental, the truck rental, and all is listed here. So the next thing we did was figure out how much exactly of this flocculation material do we need. We found out that the Chesapeake Bay is approximately 24 million tons of water. And then so we used the base cost of the clay and other materials and scaled it up. So the whole cost will be around $9 million. We found that there are 5 million tax-paying households in the state of Maryland, divided up, and found that there's approximately 69 cents for local clays for each household and $2.19 for imported clays. As Hannah mentioned before, in Florida there was a lot of red tides a few decades ago, and in order to avoid the same situation where the scientists had created an effective mitigation strategy but couldn't do it because of public opinion opposition, we decided to survey constituents of Maryland, mostly residents, and some of the questions that we asked in our survey were 6 basic demographic questions regarding age, gender, education, racial background, geographic location, and household income. The survey included questions that some of the questions that we analyzed in our survey were: if research scientists were to create a natural sediment mixture that could kill the algae bloom without harming plants and animals while also restoring natural grasses, would you support the use of the mixture in the Chesapeake Bay? And the answer choices were yes, no, and maybe. The second question that we focused on was the bloom mitigation method we are proposing involves assembling a mixture of underwater plant seeds, local sediments, and chitosan, a derivative of shells from sea crustaceans such as crabs and shrimp. And the mixture would be placed on boats, then sprayed directly on the algal blooms using hoses. If the state sought public funds to support the bloom mitigation method, how much would you be willing to pay? And the answer choices we gave were less than $1, $1 to $2, $2 to $5, $5 to $10, I don't know, and other. And the remaining questions related to the level of recreational activity on the Bay watershed and the impact of the health of the water that we gathered through information regarding how much participants of the survey interacted with the Bay and how concerned they were with the current conditions of the Bay, and if they would support any cleanup efforts. Our survey groups included 4 main groups. They were the Maryland community students and families, farmers, watermen, and municipal league members. We first started out by surveying people online via social networks. Then we surveyed during the Maryland Day this past spring. During the summer, we surveyed at the Caroline County Farmers Bureau Picnic, and in the fall, we surveyed at the Calvert County Watermen's Day Festival. And in November, we also surveyed the Maryland Municipal League members. So we got a wide range of people of all different economic statuses. And the reason for the diversity is because many people live in the Bay watershed area, and many different people live in the state of Maryland. Even though we don't all live by the Bay watershed, we all pay taxes, so we have to get everyone's opinions. And now Neil will be sharing her part. And we found that the municipal league members had the highest rate of support, whereas the farmers and watermen had lesser levels of support because an explanation for the discrepancy could be that during the summer when we surveyed the farmers and watermen, we didn't have as informative of a presentation. It was a very informal setting in which the farmers were having a social event, and we kind of just showed up with our surveys. Whereas at the municipal league conference, we had distributed information sheets that had graphics and thorough explanations of what our project is actually about. That was it.
Hi, my name is Neil, and I'm talking about the future implications of our research. So the overall purpose of our mixture was to improve the quality of the water so we could prevent any recurring blooms in Chesapeake Bay. So instead of leaving the area with a hypoxic bloom, we would be leaving the area with a higher oxygen content fewer excess nutrients, and more vegetation. So with our mixture, we were able to accomplish two main goals. One being that the dissolved oxygen levels were increased, so that reduced the effects of dead zones. And the second was the chance of recurring blooms were decreased due to lower nutrient concentration in the water itself. Second, with SAB restoration, we're trying to, SAB restoration was enriched by the release of nutrients of dying algae. Seeds in the flocculation were better grounded than those that were released without flocculation. And flocculated algae may act as a fertilizer for SAB, increasing overall biomass. Future research. So we weren't able to test the macrocystis growth phase with the efficiency of our mixture. In other words, we don't know if an older bloom will flock better than a younger bloom. Second, we wanted to be able to determine the cell density of an algal bloom, so we know how much clay and chitin we need to add to that bloom itself, so we know if it can flock better or not. Third, we also wanted to look into how often a bloom can reoccur in the test day itself, so we know if we need to flock the bloom again and again and how often. And fourth, we want to know if our mixture can work on any other algae, because we're only using a macrocystis. So we want to be able to see if clay population technique can be used to mitigate other species of harmful algal blooms in Chesapeake Bay and beyond. With the SAB impacts group, they want to further look into the impacts of the mixture on existing SAB beds, the effects on fish and benthic organisms, impacts of regrowth of a Macrocystis aeruginosa, determination of the natural half-life of macrocystin, and determination of the amount of time it takes for Macrocystis aeruginosa to die under dark conditions. Okay. Lastly, our ultimate goal is for the state to adapt our mitigation technique and for them to implement it itself so that they can use that to mitigate harmful algal blooms in Chesapeake Bay. So over here we have an example of of a bloom in Lake Taimu in China. And a Greek scientist named Gang Pan and his team were able to do a wide-scale flocculation on a harmful algal bloom. So here it just shows the pictures. On the top you have a full-scale bloom, and there's like clay flock, done to it. And on the right, you can see that man is trying to hose the actual bloom with the clay flock and stuff. And then over here on the bottom, you can see the actual flocculation process. And at the end, you can see that the water is clear. So it worked. And then here are acknowledgements, and then questions.